Here is a question. It is a question of class ninth, chapter number 3, atoms and molecules. So the question is that we have to write the formulas of first part is the sodium oxide, second is the aluminium chloride, third is the sodium sulphide, and the fourth part is magnesium hydroxide. Okay, now move to part number 1. So first part is the sodium oxide. Okay, so we know that sodium having a symbol Na and oxygen having a symbol O. Okay, so first we have to find the valencies of sodium as and oxygen. So we know that sodium having symbol Z is equal to 11, and electronic configuration of sodium is the 2, 8 and 1. Okay, that means in the first shell 2 electrons are there, in the second shell 8, and at the last in the last shell 1 electron is there. Okay, so now in the outermost shell only 1 electron is there. Okay, but we know that outermost shell it should be 8 electrons, or 8 electrons should be there in the outermost shell. Okay, so it is very difficult for the sodium, okay, to gain 7 electrons instead of losing 1 electron. Okay, so sodium lose 1 electron instead of gaining 7 electrons to fulfill its octet. Okay, so that is why the valency of a sodium is 1. Now in the case of oxygen, so oxygen having symbol is 8, so the electronic configuration of oxygen is 2 and 6. Okay, so we know that in the outermost shell 8 electrons should be there, so but here only 6 electrons are there, so that is why it is easy for the oxygen to gain 2 electrons instead of losing 6 electrons. Okay, so that is why the valency of oxygen is 2, because if the oxygen gain the 2 electrons, then in the outermost shell it will be 8 electrons there. Okay, so that is why the sodium having a symbol of 1 and sodium having a valency 1, and the valency of oxygen is 2. Okay, so now write the symbols for the sodium and oxygen to find the formulas of the sodium oxide. So sodium having a valency 1, write the valency at here, and the valency of oxygen at here. So now cross these valencies. Okay, so when you cross these valencies, means the valency of oxygen right at the sodium and 1 to the oxygen, then you will get the formula Na2 and oxygen and O, Na2O. Okay, so this is the formula for the sodium oxide. So in this way we can easily find the formulas of different types of compounds. Okay, so this is the first part for the sodium oxide. Now second part is the aluminium chloride. Okay, so we know that aluminium having symbol Al and chlorine having symbol Cl. Okay, so again the procedure is the same, that we have to find the valencies of aluminium and chlorine. Okay, so we know that aluminium Z it is equal to 13, that means atomic number is 13. So now what is the electronic configuration? That is 2, 8 and 3. Okay, so in the outermost shell here 3 electrons are there. Okay, but we know that in the outermost shell it should be 8 electrons. Okay, so but here only 3 electrons are there, so that is why for the aluminium it is easy that to lose these 3 electrons instead of gaining 5 extra electrons to fulfill its outermost shell. Okay, so that is why aluminium having valency 3. Okay, so it has valency plus 3. Okay, now chlorine, for the chlorine atom Z it is equal to 17, atomic number is 17. So what is the electronic configuration? That is 2, 8 and 7. That means in the first shell 2 electrons are there, in the second 8, and at the last 7 electrons are there. Okay, so you can see here 7 electrons are present in the outermost shell. So it is easy for the chlorine atom to gain 1 electron instead of losing 7 electrons, because it needs an extra energy. Okay, so that is why chlorine gain 1 electron, okay, to fulfill its octet. So that is why chlorine having valency is 1. okay, that is -1 because the chlorine will gain 1 electron, so it has valency -1. So now what is the formula for the aluminium chloride? So first we have to write the symbols for the chlorine and aluminium at here, chlorine at here. Okay, so we know that aluminium having valency 3 and chlorine having valency 1. Now cross these valencies, okay, and you will get Al1Cl3, okay, or simply AlCl3. So that is what the formula for the aluminium chloride. Now third part, that is sodium sulphide. Okay, so sodium having symbol Na and sulfur having symbol S. Okay, so the valency of sodium we already calculated in the first part, that is +1. okay, so we already calculated the valency of sodium. Now for the sulfur Z, it is equal to 16. Atomic number of the sulfur is 16. So what is the electronic configuration? 2, 8 and 6. Okay, that means in the first shell 2 electrons are there, in the second shell 8 are there, and in the third shell 6 electrons are there. Okay, so but we know that in the outermost shell it should be 8 electrons should be there. So that means for the sulfur it is easy to gain extra 2 electron instead of losing 6 electron to complete its octet. Okay, so that is why sulfur gain 2 extra electron to complete its octet. Octet means 8 electrons. Okay, so that is why sulfur having valency that is -2. Okay, because the sulfur will gain 2 electrons. Okay, now to find the formula for the sodium sulphide, so first we need to write the formulas for the sodium and sulfur at here, and then we have to write the valencies. For the sodium it is 1, sulfur it is 2. Okay, and no need to write the positive or negative, simply we can write the valencies over here, then cross these valencies. Okay, then you will get the formula for the sodium sulphide, Na2S. Okay, so that is what the formula for the sodium sulphide. Now the fourth part is the magnesium hydroxide. So we know that magnesium having symbol Mg and hydroxide having symbol OH. Okay, hydroxide. Now for magnesium we know that Z, it is equal to 12. Atomic number of the magnesium is 12. So what is the electronic configuration of magnesium? That is 2, 8 and 2, because in the first shell 2 electrons are there, in the second shell 8 are there, and in the third shell again 2 electrons are there. Okay, so it is easy for the magnesium atom to lose these 2 electrons instead of gaining 6 electrons to complete its octet, because we know that in the outermost shell 8 electrons should be there. Okay, so if magnesium lose these 2 electrons, so in the outermost shell 8 electrons will be there. Okay, so that is why magnesium lose these 2 electrons. So that what is the valency of the magnesium is +2, because magnesium lose 2 electrons. Now come to the OH, that is hydroxide. Hydroxide having valency is -1. But the question is how? So we can take an example, say water, H2O. So we know that when the water is dissociates, so then it dissociates into H positive plus OH negative. Okay, so because hydrogen here having atomic number is 1 electron is present in the case of hydrogen. Okay, so it has valency is 1, so that is why OH negative also having valency is 1. Okay, but in this case hydrogen lose 1 electron, but the OH it gains 1 electron, so that is why it has a valency -1. Okay, so valency of a hydroxide is -1. Now to write the formulas for the magnesium hydroxide, so we will follow the same process. First we have to write the formulas for magnesium and hydroxide, Mg and OH. Then we have to write the valencies. Magnesium having valency +2. Okay, so we can simply write 2. Okay, no need to write the plus or minus. And OH having valency 1. Then cross these valencies. Okay, and we will get the formula, that is Mg1 OH2. Okay, be careful here, it should here bracket is there, because 2 is the valency of the magnesium, but when we cross this valency, then this valency is over the O and H, means over the both. Okay, so what is the formula for the magnesium hydroxide? MgOH2. So that is what the formula for the magnesium hydroxide. Thank you.